Hi, it's Dave here from MegaPoints Controllers. I'm back on Pete Waterman's Making Tracks 4 layout installed at Blakemere, and I've had a number of questions raised about how we do the lap counter. So at the exhibition we have a large TV. Let me see if I can find it for you. It's on the wall, and this shows us our running totals for the day. So the left hand side is exhibition totals, and the right side is what's going on during a particular day, today in this case. So I'm here early, we've run nothing yet, so you can see it's all zeros. So I'm going to go into what happens on the layout to give us these totals on the dashboard we're running on the wall. This is actually a front end to a website. We've not published the URL because it's been overloaded and it's prevented the whole thing from running, so we've moved it to a new location that is hidden and firewalled off for now, and we'll make it public towards or at the end of the exhibition. To couple with this, we have a network diagram. Let me find this for you. I'll swing it round and I'll show you on screen as well. So we have the network diagram here, and it shows us exactly which boards are on each baseboard. So for example, here we can see that this baseboard has a mini panel with its CAN ID and an auto signal with its CAN ID. And we have various boards. Some of the boards at the fiddle yard baseboards have lots of boards, so we can see this one has 4 plus an auto signal 5. The funny numbers at the tops are the CAN IDs of, the V ports of the auto signals, and these are the masked V ports for each signal, so that will transmit the status of each signal. This mass of numbers here, we've numbered the tracks 4100, 4300, 4500, 4700, and these denote the 4 tracks we have, and each of these is the V port of a block detector. So why am I talking V ports? Well, everything lives in a database, and that means data. So if we take a look now, so if we go back to the screen and I bring up the network monitor, so this is our network monitor, and what this does, its only job really is to transmit data to the database, which is on a web server on the internet. So the way that works is every single CAN packet is encapsulated and transmitted, and we have a front end on here. So this is the live data viewer. There we go. I'll reconnect to that. So this is the live data viewer, and it's showing, it's timestamping all of the packets from the network that are being uploaded into the database. The column on the extreme right is the size of the queue depth. So if we were to have, for example, a slow internet connection or an intermittent failure, then we would buffer up to 7,000 packets on this product, and they would then be bulk loaded. So at the moment this is uploading packets in single packets. As they come in, they're being uploaded to the database, so it's real time. But it is capable, if the queue gets beyond 10 packets in the queue, it will start to upload in chunks of 10. This column with the 1400s is the CAN ID of the board that's sending the data. The 1 indicates that it's an operational message, so it could be a block on, block off, it could be a turn a point, move a point, something that needs switching. And then the 18 and the 121, 123 and so on, these are combined to make the V port. But this is how the data gets into our internet database. And then the query is refreshed once a minute on screen, so it's absolutely accurate. Now we're taking in data from all of the network, not just from the system 2. So one of the important or most important parts of the data collection are the RFID tags. Let me run you over and show you those. So here are the RFID tags. Each loco or each train has a unique tag attached. As I say that, here's an engine going across with no tag because it's on the train, and we've run into a point that isn't set. So they've shorted out the layout because of the frog polarity is incorrect. So that's been fixed, reset, and off it'll go. You just provided a perfect video example, thank you. And now we'll see the engine disappear. So the red reader here shows the tag of the last train that went past, and it displays for a couple of minutes. I can't remember the timeout, but it does time out and then it'll turn off like this. So there are 2 readers on each end of the layout. Here I'm looking at the up line, so this is the up slow and the up fast. Are you going out, Mark?
I can do.
Please say yes, thanks. So here's a 350 going out now on the up fast line. It's going to run through the tag reader. If you can just stop it before the tag hits, Mark, we can show people. It's on the last coach. So it's quite a bulky tag here, so it's buried under this sticker. This is our tag, and when it hits this reader, then its tag ID will be displayed here. When you're ready. And it's tag number 19 in this case. And if you heard that bing bong, that tag is also being used to drive the departure board here. So we've a database in the departure board that's received the tag and sent the information to that departure board. We've got something going through on the up slow, so let's see that. And it's just pinged, and this is train number 47. And that's just gone through on the tag as well, and that's on the departure board. So the data from the RFID tags is being used not only to drive the departure boards, but we're putting it into our database so that we can use it to calculate exactly how far every train has travelled. I've heard queries about how do we know how accurate it is. Well, let me tell you, during our Guinness World Record we had to measure track. It was 4 times the size of this, and we measured it to the satisfaction of the Guinness World Records adjudicator. But on this layout we've taken it a bit further because, well, we're all playing with toys at the end of the day. So we've measured each track to within an inch of its life. We think we've got it to less than 5 millimeters. So because we know the distance for each of the 4 tracks, every time a tag goes through the tag reader, then we know how far it's going to travel to come back. So with every train on every track being tagged, we can see exactly at what distance that has travelled to return to the same point. And obviously, because we've got a loop, all 4 tracks are different. So I think what I'll do now, let's just have a look at the board for today at the moment. Now we've got an up slow and an up fast train that's travelled, and we can see we've got some bar charts there. So we've achieved 4 laps. Can I get that light out? No. So what we'll do now is I'll take you back to my workshop and we'll have a look at the data as it's streaming in. I'll be about 5 or 6 miles up the road, so we'll see it as it's happening. The thing that impresses me about the Making Tracks team and the rail nuts is that this layout, it really is constructed by all manner of people with all manner of skills. Other than the commercial product of the Z21 and Russell's excellent departure boards, which you've seen in a previous video, everything here is either ready to run stock, off the shelf track, or we've made it ourselves. So all the electronics we've made and designed ourselves, the buildings made and designed ourselves, and of course the scenery. And no one works harder than Pete building this layout. He's frequently in the barn on his own during the week when there's no one else there, just getting on with the scenery touches and the areas of his expertise. Before I disappear back to the workshop, I'll just mention 1 or 2 improvements we're going to try after the exhibition while we've still got the layout up. So you will have seen a train run a point at the other end. And when it runs a point and the point's set against it, two things happen. First of all, we'll get a short circuit because the frog relay is in the wrong position. We know we could fix that by automatic frog switching, but it doesn't solve the problem because then everything else will derail. So we just block it by stopping the train, killing the power, and waiting for the operator to fix it. And when you're 60 odd feet away, it can be hard to tell what's happening at the other end of a layout. So things that go wrong are operator gets busy, or the operator forgets to change a point, they're distracted, or if they're on the outside track and they are acting as an instructor for a guest driver, then they could be running around like a headless chicken trying to catch a young child who's run off with a train at 300 miles an hour. So there's many things that can happen. Also, we have multiple people sharing the same line operating, and you can see that from the colour jackets. Let me find you an example. We've got Rob over here and Mark sharing the blue jackets, and this denotes the line they're on. If we look, the line, it's the up slow, and it has a blue tag, green tag, yellow tag and red tag. And these tags denote which line a person is operating, and you can see it from the colour of the jacket. A selection of coloured jackets. If you see somebody wearing a white jacket, then they're in a role that's not line assigned. So they could be supervising, they could be encouraging people to drive, handing out tickets and signing them, or just providing running interference to the public as they ask questions. So let's get back to our errant point problem. So as a point is overrun because an operator can't see or is otherwise busy, and they do get busy, one of the things we're going to do is, just at this point here where a train will depart, we're going to put a block detector on each road, and we're going to link the block detector via a mini panel to the System 2 router. So if it sees wheels on this, it will throw the point for you, so effectively you don't have to set the point on the outbound track. That also means that we'll be remaking and redesigning these panels to cope with the newer technology. These panels have a toggle switch. If I use this one, which is part of Milton Keynes, so it won't do anything here. This is the state switch because it's a physical switch and it's a latching toggle. Whereas the new panels will have single push buttons on either road. So in the fiddle yard, you can touch the road you want to come in and it will set the point appropriately. But if you happen to run this and it's set incorrectly, as I'm showing here, then the point will throw just as you arrive and allow you to exit. So that's one of the new things we're going to trial, and I'll let you know how we get on through another video update. So this is the dashboard. I'm currently in my office workshop 5-6 miles away. So this is a web front end, and it's showing us totals for today as they are live. So almost 4,000 laps, 106.7 miles, 109 laps today, and 2.91 miles today. The left hand side are exhibition totals. So we can see here we're sorted the bar chart by lines. So the up slow is the most popular line at the moment, followed by the down slow and then the up and down fasts. Per today, we can see that the up slow is getting more than its fair share of traffic, then the down slow and the up and down fasts. Now, because the up and down slow lines are operated by us, we have 2 operators per line. So it stands to reason that these lines are going to see more traffic than the lines driven by the guest visitors. Plus the fact that we run a train on a line, then we stop, we do a little handover, and beforehand we explain what's to happen. So it tends to, we're very busy, but we don't get as much traffic. If we got a big queue, then we would run 2 trains per line on the public tracks. Underneath, we can see the distance travelled by each train. So the Caledonian Sleeper has done the most at this exhibition, 253 laps, or 6.76 miles. Today the London Freightliner is at the top of the charts with 17 laps and 0.45 of a mile, and we can follow it all the way down. We see here 3 trains have been taken off. I don't know which 3 because the list is sorted in order of mileage or track count. Further down I've got a little chart that shows how many miles were driven per day. So the peak we achieved 21.8 miles. The day after we were closed, so we had a private running session that evening, and this is today's just getting going, and this is split down by the hour. So we obviously started doing things at 9 o'clock. 10 o'clock we opened our first hour with 1.8 miles driven, and we're currently, it's 11:20, 11:21, and we've achieved 0.72 of a mile. Here we can see a little chart showing the network traffic and how busy it is. When we turn system 2 on, all the boards have a chat and try to update each other with the status. So if a point switch has been moved whilst it was powered off, it'll try and catch the update, but obviously the board at the other end, the receiving board, the one with the point motor attached, has to be awake. So it goes through this little handshake and tries to get everything up to date before readying the system, and then it assumes its normal dance here, and this is a normal sort of load at, I don't know, run queue of about 5 or 6, sorry, an upload queue of 5 or 6. And they also have here a little diagram showing the control system messages. So yesterday 32,000 messages were sent, today 9,000 so far, 1,000 in the last 15 minutes, 270 in the last 5 minutes, and 90 in the last minute. And if a tag is changed on a loco and it doesn't match the database, then it would appear on the orphan tags list here. So that's something more for me when trains are either changed or tags shifted. And that's how we get the dashboard, and we'll make that available to the public after the exhibition when we're not uploading data. So because our data is going straight into a database, we can do some funky stuff. Let's have a look. So here I am in MariaDB, which is a MySQL copy. We can look at the table structure. The big table is network data. This is where all the packets go, and they just go in their raw form. So if I do select count star from network data, it will tell us there are 482,997 rows in there, or network packets. If I run that query again, there'll probably be some more in it now. Let's have a go. Oh. Rerun the query. 483,031. So it's growing continuously. This is the live data. So if we look at the network data, everything gets a unique ID and a timestamp when data goes in. We log the CAN ID that generates the packet, and then we have the 8 bytes of the CAN frame. D1 is a 1 if it's an operational message or an instruction, i.e. block on, block off, move the points. D2 and 3 are combined to make the vport, and D4 through D8 are actual data, so it varies as to what that data is. If we look on the last row here, I can see a 48, 48, 52, 53. So just by looking at that, I can see it's got the format of an RFID tag. So that tag was from the 14th of December at 8:47 and 47 seconds. That's when the database saw it. And they also tack on the size of the queue. The upload queue, that is, so we can keep an eye on how busy the system is. Let's have a look. If I run this query, this will give us the total number of laps and miles we've driven in a day. We've done 107.92. That's absolutely bang up to date at the moment. And that obviously we'll publish these numbers when the exhibition has finished. But we can start to do some interesting things, and I hope you agree. It's once it's in the database, you really can start to see what's going on. With this query, I can see the trains and what they've been doing. Yeah, let's give that a go. We can see the which line a train has run on, its tag, and how many laps it's done. Let's look at the train table. And this holds the details of the description to tag mapping. We've also added a type which indicates whether it's freight or passenger. The Christmas Express is freight, that would be correct. So it is carrying parcels after all. Polar Express, passenger. So we can see all the various categories there. If we look at the RFID tags table, for example. So the RFID tags isn't a table, it's a view that I created. It simplifies querying the data, but if I look at the RFID tags, we can see that we've had 4,045 hits on the tag reader. Let's just limit it to a screen full so we can see the column headings. So not only do we get the time and the tag, but we can see the V-port, and that V-port tells us which departure board that reader is talking to, and that also tells us which track it's on, which of the lines, and we can see the CAN ID as well. The readers are, each RFID reader System 2 board has two readers on it, so the CAN ID serves 2 lines. Whereas the V-port serves 1, so that's how we can get that data. So if you want to see the queries, for example, behind the dashboard, let's look at the train totals as they stand. So we select train, description, count, blah, 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 as miles, get it by the tag, turn the tag into a name that's meaningful. And we can see here the running totals at this point in time. Caledonian Sleeper is clearly in the lead with 257 laps or 6.8 miles. So the beauty of the database is we've got so much information at our fingertips. We haven't even begun to dive in yet. After the show, we'll dig deep and see what we find, and I suspect it might be of use to manufacturers as well who are running stock on our layout, because we can actually properly measure what that stock has done.